Hey there, fellow deep divers. Are you ready to explore something that might just change how you think about coding? We're taking a deep dive into test-driven development.
Or TDD for short.
That's right. And I think this is going to be especially interesting for you.
Because you love to really understand things deeply.
Exactly.
Yeah.
Now, TDD might seem a little counterintuitive at first.
It really does.
It's all about writing tests before you write any of the actual code.
Kind of like you're building a house.
Yep.
You wouldn't start laying bricks without a blueprint first, right?
Yeah.
The tests are your blueprint.
Oh, okay. I'm starting to see the logic here.
Yeah.
So instead of coding first and then scrambling to create tests later,
Right.
we're flipping the script.
Exactly.
Yeah.
TDD encourages you to think about the desired outcome first.
Okay.
What do you want this code to do? How should it behave? You define that behavior in your tests.
So the tests act like a guide, making sure we stay on track as we build.
Exactly. And this leads to some pretty cool benefits.
I bet.
It's like having a safety net, catching errors early before they have a chance to snowball into bigger problems.
So less time spent on those frustrating debugging marathons.
Precisely. And because you're thinking about the desired behavior up front,
Right.
you naturally end up with better code design.
Okay. I'm intrigued, but I'm also a hands-on learner.
Of course.
Can we see an example of this TDD magic in action?
Absolutely. Let's say you're building a simple function to check if a number is even.
Oh, yeah.
And call it is even.
Okay, so how would we approach this with TDD?
First, we would write a test.
Okay.
It checks if our is-even function correctly identifies even numbers. We'd also want to test to make sure it correctly identifies odd numbers, too.
Makes sense. Got to cover all of our bases, but wait.
Yeah.
We haven't even written the is-even function yet.
Right? So when we run this test, it's going to fail.
Okay.
And that's expected.
Okay.
This is our red stage in the TDD cycle.
Red for danger. I get it.
Exactly.
So what happens next?
Now we write the simplest is-even function that we can, just enough to make that test pass.
Okay.
We could use the modulo operator to check if the number is divisible by 2.
Okay, so we're not trying to write the most elegant code just yet.
No, not yet.
Just enough to get that green light.
Exactly. That's our green stage.
Yeah.
And once the test passes, we have the opportunity to refactor.
Okay.
Meaning we can clean up and optimize our code while making sure the tests still pass.
So it's rig green refactor.
Yes.
Kind of like a traffic light guiding our development process.
Exactly. And this cycle repeats with each new feature or change we make.
Nice.
Now, this was a simple example.
Okay.
Let's imagine something a bit more complex.
Okay, like what?
Let's say you're building a feature that fetches data from an external API.
Okay.
There's a lot that could go wrong there, right?
Yeah, definitely.
The API could be down, the data format could be unexpected, you name it.
Yeah, I can see how that could get messy quickly.
With TDD, you would write tests for all of those potential scenarios before even writing the code to handle the API call. This forces you to think about error handling, data validation, all those crucial details.
So it's like anticipating those bumps in the road before you even start driving.
Exactly. And when those bumps inevitably come, you've already got the tools to handle them gracefully.
Okay. I'm starting to see how TDD could really level up my coding game.
Awesome.
But are there any downsides?
Yes.
Or challenges that I should be aware of?
Of course, no approach is perfect, right?
Right, so let's talk about the potential pitfalls in the next part of our deep dive.
Sounds good.
Stay tuned, folks. Welcome back to our deep dive into the world of test-driven development.
We're excited to be back.
In the last part, we left off talking about some of the potential downsides of TDD.
Right. We wanted to make sure we gave you a balanced perspective.
Because, let's be honest, no approach is perfect, right? So what are some of the challenges developers might face with TDD?
Well, one common concern is that TDD can feel like it slows down development.
Really? Yeah.
Initially?
I can see that, yeah, you're spending time writing tests before you even start coding.
Exactly. It's an extra step in your workflow. But here's the thing. We know you value thoroughness and quality, right?
Absolutely.
Well, TDD aligns perfectly with those values. It's like studying for an exam before you take it. You might spend more time preparing, but you're much less likely to make mistakes.
Okay, that's a good analogy.
Yeah.
So the initial investment in testing pays off later with fewer bugs and a better understanding of the code.
Precisely. It's a long-term gain. And let's be real, debugging is the worst, right?
Yeah.
TDD helps minimize that pain.
Sold. But what about the situations where TDD feels really difficult to apply?
Yeah.
Like what if I'm working on a super complex feature?
That's a valid concern. TDD can be more challenging when you're dealing with really intricate features, especially those with lots of user interface elements.
Yeah, I was thinking about that. All those buttons menus, animations. It seems like testing that would be a nightmare.
It definitely requires a different approach. Traditional unit tests, the kind we've been talking about, are great for testing isolated pieces of logic. But for UI-heavy features, you might want to consider behavior-driven development, or BDD.
Okay, so BDD focuses on testing the behavior of the system from the user's perspective, right?
Exactly. Instead of testing individual functions or methods, you're testing how the system as a whole responds to user actions.
So it's like testing the actual flow of using the app rather than just the individual components.
Precisely. And BDD tools often let you write tests in a more human-readable language, which can be really helpful for collaboration.
So it's not a case of choosing TDD or BDD. It's more about finding the right tool for the job.
Exactly. And even within the realm of TDD, there are different levels of testing. You have unit tests, integration tests, and end-to-end tests.
Okay, break those down for me.
So unit tests, as we've discussed, focus on testing small, isolated units of code. Integration tests verify that different parts of the system work together correctly.
And end-to-end tests simulate real user scenarios to make sure the entire application flows as expected.
You got it. And by combining these different levels of testing, you create a really robust safety net.
Okay, I'm starting to see the bigger picture here, but let's talk about real-world applications. In the last part, we touched on using an API as an example. Give me another scenario where TDD would shine.
Okay, imagine you're building a website for an e-commerce store.
Okay.
There are so many critical functions that need to work flawlessly, right?
Yeah.
Adding items to a cart, processing payments, managing inventory.
Yeah, any errors there could be a disaster.
Exactly. With TDD, you could write tests to simulate all sorts of user interactions and edge cases. What happens if someone tries to buy more items than are in stock? What if there's a problem with the payment gateway?
Okay, so you're not just testing if the code works in ideal conditions. You're also testing how it handles unexpected situations.
Precisely. It's about building resilience into your application. And TDD forces you to think about those potential problems up front.
I bet companies like Amazon use TDD extensively for their website.
Oh, absolutely. They have to. With millions of users and transactions happening every day, their systems need to be rock solid.
Okay, so we've seen how TDD applies to web development, but what about something like game development? Is TDD relevant there?
It absolutely is. Game development often involves complex interactions, physics simulations, AI, all sorts of intricate systems.
Yeah, you don't want your game crashing in the middle of a boss fight.
Exactly. TDD helps ensure that all those systems work together seamlessly and reliably. You can test different game mechanics, character abilities, AI behaviors, all sorts of things.
So whether I'm building a simple function or a complex game, TDD can help me write better code.
That's the key takeaway here. And the best part is TDD is a skill that can be applied to almost any programming language or framework.
Okay, I'm convinced. But before I jump in head first,
Right.
What are some best practices I should keep in mind?
Let's dive into those in the next part of our deep dive. Stay tuned.
Welcome back, deep divers. We're in the final stretch of our TDD exploration.
And we've saved the best for last.
Oh, really?
Practical tips to get you started.
Oh, nice. Okay.
With TDD.
In the previous parts, we've laid the groundwork.
Yeah, we have.
Exploring what TDD is, the benefits, and even some potential challenges.
Now it's time to empower you with the knowledge to actually implement TDD.
Yes.
In your own projects.
In your own work.
Perfect. So let's jump right in. What's the most important thing to remember when starting out with TDD?
Well, one of the most common pitfalls I see with beginners is trying to write tests that are too big.
Okay.
And complex.
So it's better to start small.
Absolutely. Remember the even number example from earlier?
Yeah.
That's the perfect illustration.
Yeah.
Focus on testing one specific behavior at a time.
So each test should have a very clear and narrow focus.
Exactly. This makes your tests easier to understand, maintain, and debug.
Okay.
Trust me, when you're dealing with a suite of hundreds or even thousands of tests, keeping them small and focused is a lifesaver.
Small and focused tests. Got it. What else?
Another crucial practice is mocking external dependencies.
Now, we touched on this briefly before. Can you remind me what mocking is all about?
Of course. Remember when we talked about testing a function that fetches data from an API?
Yeah.
You don't want your test to actually hit the real API.
Right.
Every time you run it.
Yeah, because that could slow things down.
Yeah.
And introduce unpredictable results.
Exactly. Mocking lets you simulate those external interactions in a controlled way. You basically create a fake version of the API that returns predictable data.
So it's like creating a stand-in for the real API just for testing purposes.
Precisely. This allows you to isolate the code you're testing and ensure that your tests are focused solely on its behavior.
Okay, mocking makes sense. Any other TDD wisdom to impart?
Definitely. Embrace the power of automation.
Okay.
Continuous integration and continuous deployment.
You're right.
Or CI/CD are your best friends.
Now, those terms sound a little intimidating. Can you break them down for me?
Sure. CI/CD basically means integrating your automated tests into your development workflow.
Okay.
So that they run automatically whenever you make changes to your code.
So it's like having a robot buddy that constantly checks your work for you.
Exactly. This helps catch errors early and ensures that your code is always in a deployable state. Okay, CI/CD automation got it.
Oh.
But let's be real. Sometimes, even with the best intentions, things can get messy.
Oh, yeah.
What happens when I inevitably encounter a bug?
Yeah.
How does TDD help with debugging?
That's a great question. One of the biggest advantages of TDD is that it makes debugging so much easier. When a test fails, you know exactly where to look for the problem.
Because the failing test pinpoints the specific area of the code that's causing the issue.
Exactly. It's like having a trail of breadcrumbs leading you straight to the source of the bug.
Okay, that makes debugging a lot less daunting. Any other debugging tips?
Definitely. Use a debugger.
Okay.
Most modern development environments have built-in debuggers that allow you to step through your code line by line, inspect variables, and really understand what's happening.
So it's like putting your code under a microscope.
Precisely. And when you combine that with the insights from your failing tests, debugging becomes much more efficient.
Okay. This is all starting to click.
Yeah.
But I have to admit, one thing I'm still struggling with is knowing what to test.
Yeah.
How do I choose which aspects of my code to focus on?
That's a common challenge. A good rule of thumb is to focus on testing the most critical parts of your code. Think about the core functionality of your application.
Right.
What absolutely needs to work correctly.
Oh, things like user authentication, data validation, core business logic.
Exactly. Those are the areas where errors could have the biggest impact. Start there, and then you can gradually expand your test coverage as you gain more experience.
Okay, that makes sense. Focus on the essentials first. But let's talk about something you mentioned earlier, refactoring.
Right.
How does that fit into the whole TDD process?
Refactoring is an essential part of TDD. It's all about improving the structure and design of your code.
Okay.
While ensuring that your tests continue to pass.
So it's like cleaning up and reorganizing your code to make it more efficient and readable.
Exactly. And because you have a suite of tests to back you up, you can refactor with confidence knowing that you're not introducing new bugs.
Okay, refactoring is like giving your code a makeover without breaking anything.
Exactly, and it's an ongoing process. You should constantly be looking for ways to improve your code, and TDD gives you the safety net to do that.
All right, I think we've covered a lot of ground here.
I think so.
We've talked about writing small and focused tests, mocking external dependencies, embracing automation, and even using a debugger.
We did.
We've also explored the importance of refactoring and focusing on testing the most critical parts of your code.
Yeah.
This has been a fantastic deep dive into the world of test-driven development.
It really has.
And we hope you feel empowered to start incorporating TDD into your own projects.
We do.
Remember, TDD is a skill that takes time and practice to master. Don't be afraid to experiment, make mistakes, and learn along the way.
Absolutely.
And most importantly, have fun. Because when you write better code, you ultimately create better software.
That's right.
So go forth, deep divers, and embrace the power of test-driven development. Until next time, happy coding.